Here we are going to discuss the most important organic conversion questions in the chapter amines. So accomplish the following conversion. First one, how we can convert nitrobenzene into benzoic acid. So we have the starting material as nitrobenzene, right? Nitrobenzene. So we have to convert into benzoic acid, right? Benzoic acid. So dear all, let me follow one of the method. First of all, let me convert the nitro group into amine. Nitro group into amine. So all of you try to recover what are the conversions we discussed in this chapter. How we can convert nitro group into NH2 group. You know, nitro group can be converted to NH2 group through reduction, right? Reduction. We can use iron in presence of HCl or tin with HCl, right? Anything. So nitro group we converted into amine group. All right, aniline is ready. Now aniline, let me treat with NaNO2 and HCl, you know, diazotization reaction at 0 to 5 degrees Celsius, right? Sodium nitride with HCl will at 0 to 5 degrees Celsius will give amine, right? After that, this NH2 group, what happens? NH2 group converted into N2 plus Cl minus. What is that? Benzene diazonium chloride. After that, you have to get benzoic acid. There is not a direct method to convert which one? The benzene diazonium chloride into benzoic acid. So what we have to do that? First of all, we have to treat it with a CuCN. You know, CuCN, or we can treat it with the which one? KCN, potassium cyanide. So we will get cyanide on benzene ring, right? Benzene diazonium chloride, when you treat it with the CuCN or KCN, we will get cyanobenzene. Next thing, how we can convert cyanobenzene into benzoic acid is ready. Cyanide on complete hydrolysis. Cyanide on complete hydrolysis will give you a carboxylic acid. Means benzene with COOH. So we can add water in presence of an acid. So cyanide on complete hydrolysis, it will give you carboxylic acid. So once again I am repeating, nitrobenzene on reduction, aniline. Aniline on diazotization, diazonium salt, which is all treated with a CuCN, or we can use KCN, okay? CuCN or KCN. Cyanobenzene. Cyanide on complete hydrolysis, the product is which one? Benzoic acid. Second question. How we can convert benzoic acid into aniline, right? Benzoic acid into aniline. See the almost reverse question. So as a starting material, we have benzoic acid, benzene with the COOH. Now student, what is aniline? Aniline means benzene with NH2 group, right? Benzene with NH2 group. You see here all, in benzoic acid, there is one carbon on the benzene ring, but in aniline, there is no carbon. So we have to reduce the number of one carbon. So definitely in this chapter, aniline, this amine chapter, we are mainly dealing one carbon less product, that is through Hofmann-bromide degradation reaction, right? So first of all, let me convert our carboxylic acid into amide. How we can convert carboxylic acid into amide? Either we can carry SOCl2, you know, thionyl chloride, or we can use PCl3, or we can use PCl5. Any one of the chlorinating agent, if you are using on a carboxylic acid, the carboxylic acid converted into benzene with COCl. That is called what? Benzoic acid on chlorination, it will give you, means a chlorinating agent SOCl2 or PCl3 or PCl5, it will give you benzoyl chloride. What is this compound is called? Benzoyl chloride. Benzoyl chloride. You see, benzoyl chloride when you treated with ammonia, benzoyl chloride when you treated with ammonia, it will give you amide, right? It will give you amide, benzene with CONH2, right? Benzoyl, acid chloride, when you treat with ammonia, your product is an amide, right? A amide, how we can convert it into amine? And here, one carbon should be less. Dear student, during Hofmann-bromide degradation reaction, what we are doing, the CO group, we are removing from the group, right? To write the product directly, okay? From the amide, the CO group, when you're removing, yes, your amine is ready, benzene with NH2. What is the reagent we are using during bromination? Bromine in presence of a base NaOH. right? Bromine in presence of NaOH. Once again, here the question to convert benzoic acid into aniline. Here benzoic acid on the benzene ring there is one carbon, but on aniline there is no carbon on benzene ring, right? So benzoic acid first adding with a thionide chloride PCl3 or PCl5, acid converted into acid chloride. Acid chloride treated with ammonia, this HCl will go, you will get NH2 amide. This is called what? Benzamide. Benzamide on Hoffman bromamide degradation reaction, it will give you aniline. Clear? Next question. Benzyl chloride. So our starting material is benzyl chloride. What is benzyl group, dear all? Benzene with a CH2. Benzyl. This is benzyl chloride. We have to convert into 2-phenyl ethanamine. So ethanamine is the parent chain. So total 2 carbons are there, and one of the carbon connected to amine, so ethanamine. So one, this is the carbon number 1, carbon number 2, second carbon atom carrying 1 phenyl group. This is the compound we have. So let us fill the valency like this. Okay, so this is the compound. So dear student, amine is the major group here. So number 1, number 2, 2-phenyl ethanamine. All right. So how we can convert benzyl chloride into 2-phenyl ethanamine? See the difference, main difference. On the benzene ring, we have 1 carbon in benzyl chloride in your reactant, but on your product side, you have 2 carbon on the benzene ring. Yes or no? Yes or no? So there are 2 carbon on the benzene ring. So we need a step up method. We have to increase the number of 1 carbon. In the previous lectures, we studied how we can increase the number of 1 carbon. Majority reaction, we have to bring a cyanide group if you want a step up method, mean if you want 1 carbon extra. Okay, let me bring one of the cyanide group here, dear all. So let me treat with how you can convert a chlorine into cyanide. We can treat it with the KCN, right? KCl will gone, CN will substitute, so you will get cyanobenzene. All right. Now the next thing, cyanide is there, so CH2CN, right? Not directly CN, which one? CH2CN, correct. CH2CN, right. This chlorine is going and the cyanide is substituting. Okay, CH2CN, all right. Now the next thing, how we can convert cyanide into amine. Cyanide into amine. You know, cyanide on reduction will get amine. What is meant by reduction? Addition of hydrogen, right? To the carbon, add hydrogen, it becomes CH2. To the nitrogen, you add hydrogen, it will be NH2. So that is CH2NH2, right? So cyanide on reduction, you will get CH2NH2. The reducing agent is which one? We are using hydrogen in presence of nickel. Or we can use the strongest reducing agent, lithium aluminum hydride, or we are using sodium amalgam, right? Sodium amalgam with ethanol. Any of the reagent is fine for the reduction of cyanide into amine. Once again, all of you, benzyl chloride and the product, when you consider there is 1 carbon extra in the product side, so you have to add 1 KCN, so cyanide is groups coming. What is the need of the cyanide here? So when you add cyanide, 1, 2, yeah, so 1 carbon increased. Correct. So if you want 1 carbon extra in the product side, maximum try to bring a cyanide group. That's called step up method. Okay, the final one. Next thing, chlorobenzene. So starting material is chlorobenzene to para-chloroaniline. Chlorobenzene to para-chloroaniline. What is para-chloroaniline? So para-chloroaniline. So this is our aniline and this is para position. There is a chlorine. All right. So we need a amine group. All right. We need a chlorine is already there. We need an amine group, right? Okay. So let me add first of all nitro group. What is nitration? Concentrated nitric acid and concentrated sulfuric acid. This is our nitrating mixture. You will get a nitro group. Where the nitro electrophile, you know, nitration, chlorination, everything is electrophilic substitution. Where this electrophile can attack, it is decided by the existing group on the benzene ring. Who is that? Chlorine. You know, halogen on benzene ring act as a ortho-para directing group. So the nitro group can goes to either ortho and para. We need para product. We see the aniline is on para, right? Even para is the major product, right? Yes. So we can write chlorine is there. Chlorine is there and we have nitro group. All right. Okay, so para, right, para position nitro group is ready. So chlorobenzene already there, para position nitro group. Now what is our next purpose? Nitro group we have to convert into NH2 group, that already we discussed through reduction. We can use iron in presence of HCl, or we can use tin with HCl, SN, tin with HCl, any one of them is fine to convert nitro group into NH2 group. Right, student? Both compounds are same, right? So don't worry about the position of chlorine. Here up, here on the top, here at the bottom. No, while numbering, it will be same. Okay. So chlorine, the para position nitro group on reduction, we got NH2 group. Clear? Next one. Aniline into para bromoaniline. So our starting material, let me take it as aniline, NH2. Alright, NH2, and our final product is para bromoaniline. So this is our para bromoaniline. Okay. So dear student, you may studied one of the, in the electrophilic substitution of aniline, you have studied about bromination, nitration, etc. There is a large difference in their bromination process and nitration process. Normally, you know, aniline is a very strong ortho-para directing group. Normally, while doing bromination, all the ortho and para positions are occupied by bromine. You will get 2,4,6 tribromoaniline. Hope you studied. So, aniline is a very strong ortho-para directing group. Normal bromination, all the ortho and para positions are occupied by bromine immediately. But we need only one bromine. We studied a technique just below that. What is the technique? What is the method to get monobrominated aniline, which means one bromine, especially para. You know, para is the major product. How we will get only one bromine on aniline? We studied that. First of all, we have to protect the NH2 group, because NH2 group is a very strong ortho-para directing group. We have to make it as a weak one. So what is called protection? How we can protect NH2 group, that we studied through acetylation. First you protect your NH2 group by acetylation. What is acetylation? Treating with the acetic anhydride. What is acetic anhydride? CH3COOCOCH3. This is called acetic anhydride. But mostly in examination, in the question, they will give you like this. CH3CO twice O. This is acetic anhydride, right? See all of you. CH3CO, right? Like two groups are there twice, and center there is an oxygen. Okay. So what you have to do here is very simple. When a aniline treating or amine treated with acetic anhydride, all of you, from your amine, you take one hydrogen. From this area, you take this part, which means CH3COO. So this CH3COOH is removing from the system. CH3COOH is removing from the system. Let me write the product, all of you. What will be the product? Here we have, from NH2 already one hydrogen gone, we have NH. And what is remaining in this species? COCH3. We will get COCH3. See all of you, aniline on acetylation, we are getting an amide. What is the name of this amide? We have N. Here nitrogen connected to a phenyl group. N-phenyl. N-phenyl, nitrogen connected to a phenyl group. N-phenyl, 2 carbon containing amide is called what? Ethanamide. You may study that. It's also called acetanilide, right? N-phenyl ethanamide. Now we have to convert this into, we have to bring bromine, right? Okay, let us bring bromine first of all. How we can bring bromine? Actually, we are as the reagent, we are adding bromine in presence of ethanoic acid, CH3COOH. So bromine will goes to ortho and para position, but you know para is the major one, so it will goes to para product. Okay, so we are getting the same product. We have NHCOCH3 and para position there is one bromine. Then we need our amine group back. Right? Why we did acetylation first? Because to protect the NH2 group. Because NH2 group is the main issue. He is a very strong ortho-para directing group. He is inviting all the electrophile immediately into ortho and para. We don't want that. We need only one bromine. So we protected. Now we want the amine group back. If you want to convert the amide back to NH2, we can treat it with which one? A acid water. Acid hydrolysis. H plus acid and treated with the water, you'll get the amide group converted into amine group back. So it's very important one. So see all of you, please concentrate this area. Electrophilic substitution on aniline, especially bromination, nitration, sulfonation, Friedel-Crafts alkylation and Friedel-Crafts acylation. We may study aniline cannot undergo Friedel-Crafts alkylation and acylation because they undergo some salt formation, right? Next question. Give the structures A, B, C in the following reaction. Yes, student, question number 1. Your starting material is given as CH3CH2I. What is this compound? Ethyl iodide. Is treating with the NaCN, sodium cyanide. What happened? This sodium iodide eliminated, cyanides group will substitute. You will get CH3CH2CN, propane nitride. This is your compound A. And this compound on hydrolysis, they said partial hydrolysis. Dear all of you, very careful. Cyanide on partial hydrolysis. If they specified partial hydrolysis in the question, the product is an amide. Cyanide on partial hydrolysis, it will give you amide. Cyanide on complete hydrolysis, it will give you carboxylic acid. Once again, I am repeating, please note that. Cyanide on partial hydrolysis will give you amide. No change in carbon, okay? So this is 3 carbon contain cyanide. So you will get 3 carbon contain amide. CH3CH2, CONH2, propanamide. Okay, so cyanide on partial hydrolysis will give you a amide. Cyanide on complete hydrolysis will give you a carboxylic acid. Okay, so this is your amide B. Now, when you treated with NaOH and Br2, dear student, what is bromine and alkali? Your starting material is an amide treating with the bromine and NaOH. What is the reaction? Hofmann-bromamide degradation reaction. See the name, Hofmann-bromamide. Bromamide, your starting material, bromine and amide is there. See, bromine is there, amide is there along with a base. How to write the product amine? It's very simple. From your amide, remove the CO group, remaining is your amine. So CH3, CH2 and H2 is the amine. Ethanamine, right? Ethanamine is the product. Here we need only the structures, right? No, the structures, okay. Question number 2. C6H5N2Cl. What is C6H5? You know, phenyl ring. C6H5N2Cl, that is our diazonium salt, benzene diazonium salt. When you treated with a CuCN, what happened, dear student? This CuCl eliminated, nitrogen gas is eliminated, cyanide group will come to the benzene ring. We will get cyanobenzene, all right. This is your compound A. So this is here compound C, right? Okay. This is compound A. And here all of you, please carefully listen. Here, this is a cyanide. I told you cyanide on partial hydrolysis will give you amide as a product. Correct. Here this is again cyanide, but here they didn't specify what is the hydrolysis. They just specified water and acid. This is complete hydrolysis. Okay. If they specified a partial hydrolysis, you can go with that. Or if you need as a product amide, then also you can write amide. No issue. But here they didn't specify which reaction, whether it is a complete or something. So H2O is H plus is given. So we can make into carboxy. It undergo complete hydrolysis. It will give you carboxylic acid. So cyanide converted into COOH, benzoic acid. Okay. This is your compound B. What is that next? That B undergo reaction with the ammonia on heating. Yes, student. A carboxylic acid, when you treat it with ammonia, you will get amide, right? Amide. No change in number of carbon. You will get CONH2. What is this compound? Benzamide. Alright, benzamide. So first reaction, diazonium salt treating with the CuCN, cyanobenzene. Cyanide on complete hydrolysis, carboxylic acid. Carboxylic acid on treated with ammonia, amide. Clear? So that is our last reaction. Next one. Question number 3. Starting material is ethyl bromide, CH3CH2Br, ethyl bromide. It is treating with the KCN. Again, what happened? KBr eliminated, cyanide group will substitute, CH3CH2CN, propane cyanide. And this is your compound A. It is on treated with a lithium aluminium hydride. You know, lithium aluminium hydride is a reducing agent. It will convert cyanide into amine. So CH3, CH2, CH2, NH2. Please don't make any change in number of carbon. Okay, there are 3 carbon in your cyanide, 3 carbon in the amine. Okay, this is your compound B. What is the next one, dear student? It is treated with the HNO2, you know, nitrous acid. That is nothing but diazotization. What happened? This NH2 converted into N2 plus Cl minus, diazonium salt, right? Diazonium salt. But we studied that aliphatic diazonium salt are unstable when it is converted into the diazonium salt. So when a amine, aliphatic amine, when you treat it with a nitrous acid, you will get the diazonium salt, but it is unstable. Immediately it will give you alcohol. So directly we can write the final product as alcohol. What is the final product? CH3, CH2, CH2, OH. All of you, once again I'm repeating. A aliphatic amine, if it is given when you treat it with a nitrous acid, directly you can write it as the product because it's an alcohol. Because the aliphatic diazonium salt is highly unstable, so it will immediately react with the water in the system and it will give you alcohol as a product. Next one, question number 4, C6H5NO2, that is nothing but our nitrobenzene. Nitrobenzene, when treated with the iron and HCl, which means reduction, you know, nitro group on reduction, you will get amine, right? Amine. So benzene with NH2, all right? And this compound is A, and then second reaction is treated with the NaNO2 and HCl at 273, means 0 degrees Celsius. Which means diazotization, right? NH2 converted into diazonium salt. We will get benzene with N2 plus Cl minus. Alright. This is your compound B. Dear student, diazonium salt, benzene diazonium salt, when you treat it with the water in presence of acid on heating, what happened? It will give you alcohol. Same like your previous case. So diazonium salt, when you treat it with the water in presence of an acid, it will give you the final product as phenol, OH group along with this, you know, H2O contain H plus and OH minus ion. This OH minus ion come to the benzene ring, this H plus and Cl minus removing as HCl, and the nitrogen gas is evolved. So the final product is which one? Phenol. Alright, phenol is the final product. Next one. An aromatic compound A. It's a 2 to 3 mark question, dear all of you. An aromatic compound A, okay, A, which is on treatment with the aqueous ammonia. Alright, it is on treated with the aqueous ammonia and heating forms a compound B. Alright, which on heating with the bromine and KOH. Alright, heating with the bromine and KOH, it forming a compound C with a formula C6H7N. Write the structure and IUPAC name of the compounds A, B and C. All of you listen carefully. In any of the steps, are you getting any idea about the reaction from amine chapter? Dear all, bromine, the second step, bromine and KOH means a base. Okay. Bromine and a base reaction we studied only in the chapter is which one? Hofmann-bromamide degradation reaction. So our second step is Hofmann reaction. If it is a Hofmann reaction, you know, in a Hofmann reaction, your starting material is an amide. So B is an amide. Because what is Hofmann-bromamide reaction? Bromine treating with amide in presence of base. And what is the product during Hofmann reaction? That is an amine, right? Amine, 1 carbon less contain amine. So C6H7N is an amine, that's sure. So dear student, what is actually C6H7N? That is benzene with the NH2 aniline. Aniline. Okay, aniline. What is the IUPAC name of aniline? Benzene with amine is called benzenamine. Right? Benzenamine. Alright. So benzenamine is there. That is your compound C6H7N. All of you check the number of carbon, hydrogen in nitrogen. Okay. This is the C6H7N is aniline. And this compound on heating with the bromine and KOH. Okay, so what should be B? This is your compound C. What is the compound B? Dear all, we know how we can create a amine from amide through Hofmann reaction. Normally, we will remove the CO group, right? We will remove the CO group from the amide. Your amine is ready. So, let me write that amide benzene with CONH2, right? We will remove the CO group from the amide. Your amine is ready. That's what we studied, right? So, what is this compound? Benzene with the amide is called what? Benzamide, right? Benzamide. All right, benzamide. This is your compound B. Now, if you want to get this benzamide by treating, how this benzamide is forming, dear all? How this amide is forming? By treating with the ammonia. From which compound you are preparing amide by treating with ammonia? That is from a carboxylic acid, dear student. That is from a carboxylic acid. Benzene with COOH, benzoic acid. So starting material is which one? Benzoic acid. That is your compound A. So benzoic acid on treated with ammonia, you will get amide. Right, amide. So this is benzoic acid is A, benzamide is B, benzenamine or aniline is compound number C. Clear all of you? Next one. Complete the following reaction. C6H5. So question number A. C6H5NH2. That is nothing but aniline. Is treating with the chloroform CHCl3 and also alcoholic KOH. Alright. We studied chloroform related only one equation or only one reaction we discussed in this chapter, that is nothing but carbylamine reaction. What is that? So the reaction is called carbylamine. Carbylamine reaction. It's also called what? Isocyanide test. Right? Isocyanide test. You know what is carbylamine test? It is given by only primary aliphatic and aromatic amine. Yes, it's a primary aromatic amine. And in this case, you know, when we treat a amine with the chloroform and KOH on heating, what happened? The amine group is converted into isocyanide. Alright, isocyanide. Along with the, you know, the byproducts are potassium combined with the chlorine, KCl, along with the water. These are the byproducts in reaction. So, during carbylamine test, NH2 group is converted into isocyanide. Therefore, this test is also known as isocyanide test. Alright. So, the product is which one? Isocyanide. Question number 2. Again, let me take aniline as a starting material, NH2. It is treating with a concentrated sulfuric acid. You know, sulfuric acid means H2SO4. Alright. This is called sulfonation. You may study this reaction in electrophilic substitution reaction, sulfonation. When aniline treated with a sulfuric acid, dear student, sulfuric acid contains the main ion H plus and HSO4 minus. Right, H2SO4 can give the ion H plus and HSO4 minus. You know, aniline is a basic one. By donating this lone pair, it can take this H plus ion. So NH2 becomes NH3 because it taking the acid H plus ion. So you will get the compound as NH3 plus, you know, anilinium ion, right? NH3 plus and this HSO4 minus. All of you once again. Amine is basic in nature. By donating the lone pair, it can take this H plus ion. So it will be NH3 plus and HSO4 minus is there. What is the name of this compound? You know, benzene with the NH3 plus is called what? Anilinium, right? Anilinium hydrogen sulfate. Anilinium hydrogen sulfate. We'll get it. Anilinium hydrogen sulfate. You know that this compound is ending with a zwitter ion. It can form zwitter ion. Dear student, when you heated this system, they will make a small rearrangement. You will get the compound as benzene with again NH2 on the top, SO3H. Benzene with SO3H is called sulfonic acid. And here it is a aniline with the sulfonic acid. That's called what? Sulfanilic acid. Sulfanilic acid. Sulfanilic acid, it can exist in a zwitter ionic form. You know what is a zwitter ion? Dear student, again, nitrogen having a lone pair. It's basic in nature. This hydrogen is acidic in nature. So by donating this lone pair, it can take this H plus ion back. So you will get the compound. NH2 becomes again NH3 plus and below you have SO3 minus. This compound is the zwitter ionic form. right? This is the Zwitter ionic form. What is the Zwitter ion? The same compound which having a positive and negative charge, right? It's called what? A Zwitter ion. So during sulfonation, aniline can be converted into which one? Sulfanilic acid. Sulfanilic acid can exist as Zwitter ionic form. Okay, you should end with the Zwitter ionic form when you're writing for examination. Next one, last question, third one is given benzene with aniline. All right, benzene with aniline NH2. It is treating with the compound that's already we discussed before, CH3. What is this compound, dear students? CH3CO twice O, acetic anhydride. What is that? Acetic anhydride. You know the formula. Let me just expand it. CH3CO. Once again, CH3CO. At the center, there is one oxygen, right? This is called acetic anhydride. Short form, CH3CO twice O. When you treat it, that's called what? Acetylation. During the bromination also we studied this process, acetylation. So when aniline treated with the acetic anhydride, you have to do this method here all. From amine, take one hydrogen. From your acetic anhydride, take this part. Which one? CH3COO, and this H is removing. So CH3COOH is removing. Remaining group, you just club it. We have benzene with, from NH2 already one hydrogen gone, so remaining NH and remaining COCH3. COCH3. What is this compound? We already named before, N-phenyl ethanamide. 2 carbon contain amide. N-phenyl ethanamide. It's also called what? Acetanilide. Last reaction. For the reaction, benzene with NH2. Again aniline. Here we are treating with the aqueous bromine, which means bromine water, right? Bromine water. Dear student, aniline is a ortho-para directing group. Bromine water is a very strong brominating agent. What happened? All the, this is, you know, ortho, para. All the ortho and para positions are occupied by bromine. So we'll get the compound. You studied this reaction in electrophilic substitution. NH2, bromo, and bromo. Right, what is the name of this compound? You know, aniline is the main group. So number 1, 2, 3, 4, 5, 6. 2, 4, 6. 2, 4, 6, 3 bromine. Tribromoaniline. Tribromoaniline is the final product. Okay, so very carefully, please concentrate on the electrophilic substitution of aniline part. It's very important. Let me specify the area. Nitration, bromination, sulfonation, and Friedel-Crafts alkylation and acylation. So many reasoning questions and reactions are there from this area. And mainly you have to focus on amine chapter, the nomenclature, very important. How to name the primary, secondary, tertiary amines, and how to classify them primary, secondary, tertiary amine, and their nomenclature already said. Then their all preparation. Around 6 method of preparation we studied, including very 2 important naming reaction. Hoffman bromamide degradation and Gabriel thalamide synthesis. And then we studied a lot of major chemical property like their basic character. Very sure question for exam, basic character. Study the all basic character in the previous lectures. We already discussed about that. And so many reaction, carbylamine reaction, the Hinsberg test, you know, the distinction of primary, secondary, tertiary amine, and all the conversion questions. Okay, very careful. Then physical property also important. The major physical property, they will focus on boiling point. You know, which amine is having greater boiling point. Primary greater because of more number of hydrogen, everything we discussed before. So dear all, amine chapter from the term 2 examination, from the existing syllabus, it's a smallest organic chapter. You know, the next organic chapter is aldehydes, ketones, and carboxylic acid, the highest weightage chapter. So in the upcoming classes, we will definitely deal with that one. Okay. So all of you, hope you're clear about the amine chapter question discussion. We will meet again in the next video or the next lectures for the next chapters, especially aldehydes, ketones, and carboxylic acid, chemical kinetics, electrochemistry. So many chapters are there. We can discuss those important questions in the upcoming videos. So till then, bye all of you.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.